Good morning, and thank you to be with us for this screencast, which has the objective to present to you an overview of the features of monitoring application performance with SecurActive APS. As you will see, SecurActive APS helps you measure the end-user quality of experience from users that are using the most critical applications through your network. SecurActive APS helps you identify slowdowns quickly, understand the scope and the root causes of the slowdown. Our customers use on a daily basis SecurActive APS to reduce the average time to resolution of a performance degradation problem and then increase end-user productivity and improve IT team efficiency in the monitoring of performance issues and diagnosis. The first screen that you will see is one of the main screens of APS because it's one of the most synthetic elements regarding performance. It presents as a dashboard the evolution of the end-user quality of experience compared to the service level agreements fixed by the IT department for the most critical applications. We show the evolution in time from left to right for each application using a color code, extremely simple, which shows in green that the end-user quality of experience is satisfying. In yellow, we have a start of degradation, and in red, the end-user quality of experience is not satisfying. When we have seen this to be the case, we can consult each box, which represents a given time for an application, the index value, which represents the end-user response time or quality of experience. The end-user response time and the number of transactions that have been impacted by the performance degradation are shown. From a single click, we will be allowed to access to more detailed information for one application, as we have done, and see a second dashboard which shows us for a given application the EURT evolution, that is to say, the end-user quality of experience over time. This is the curve shown here, with three colors, which represent three metrics that impact the end-user quality of experience. That is to say, network latency, server response time, and the data transfer time through the network. We can see here the evolution with three different colors that we can isolate with ease in order to understand the impact of all of it on the end-user quality of experience. In parallel, we can see a purple histogram which show us the evolution of the load application, that is to say, the number of transactions in time. This helps versus to correlate the degradation of the server response time as an example with a usage peak at the application level and a huge number of transactions at a given instant. Under the two first graphics, we find two zones which show us the decomposition of end-user quality of experience according to, at the left, the application server which the user is using, or at the right, according to user's location, as an example, a site or a VLAN. We will be able to understand immediately if a server provides a much lower performance than its counterparts, or if we observe a slowdown, is this slowdown impacting more one site versus another. As we can see here, we can observe that the Turin and Lisbon sites have performance widely degraded comparing to their counterparts, but for different reasons. Because the Turin site is impacted by server response time, and the Lisbon site by a data transfer problem through the network. In the same manner, if we want to have access to detailed information, we can do that easily by clicking on the bar that represents the Lisbon site, and by seeing the performance of a given application for the single Lisbon site. What will we observe? We will observe a peak and an end-user quality of experience degradation, which is mainly guided by the metric we call DTT, and which represents the data transfer time through the network. And to know more precisely if all Lisbon users were impacted by this slowdown, we will be able to see somewhat lower in the dashboard the decomposition of the performance and end user quality of experience between the different hosts which are located on the Lisbon site. We will observe a basic difference in EURT metric because one client has an EURT of 1.5 seconds when the other has an EURT of 465 milliseconds, and we observe clearly that the DTT makes the difference. We will understand by observing the traffic quantity associated to this user that the transfer application response, which are much more important than the others, which leads to a different transfer time, much more important. In order to get more details, we can click once to see the conversations between a client and server and observe the performance of this single conversation. Now we observe a retransmission rate to the client towards the server that's very important. In parallel, we can search other information, for example, TCP errors or anomalies, which have been observed in this conversation. And what we will see here is some resets done by the client. In this conversation, what we can conclude is that connections or deconnections were done by the client and not the server. In order to refine the analysis, we can also observe the network performance between the Lisbon site and the data center and visualize on the one hand the network response time and on the other hand retransmissions viewed by rate or delay, that is to say, retransmissions impacts for the end user quality of experience. We can see a retransmission peak from the client towards the server looking to the blue curve that shows us a retransmission peak and green curve in response time which shows us end user quality of experience impacts. As you can see here, this is only an overview of SecurActive APS and numbers. There are many detailed features. For more information, please contact us or visit our website at www.securactive.net. Thank you and see you soon.